But what we want to do right now is we want to look at this week. So what are we doing for the laboratory this week? So let me find the experiment. Okay, so this is your same experiment. So thankfully, we are just doing the second part of it. We already did the visual. That was last week. So this time, we're doing the spectroscopic monitoring. And we would use the spectrophotometer. We have desktop spectrophotometers just sitting there doing nothing, unfortunately, but we're going to pretend. So you have the same learning objectives. We have the same possible mechanisms. So we are still exploring the same reaction. We're still exploring the iodide plus thiosulfate, and this is supposed to be a reaction arrow. So same. We still have the same exact mechanisms. We should get the data to relate to our visual. So we still have the mechanism 1, and we have 2 possible steps. So this is saying that, oops, okay, if our rate law, remember, this is our rate law. So when you're answering the question and it asks you to give the rate law, this is the form of a rate law. And because we are doing a specific experiment, you would want to give this as your rate law if it is indeed the rate law. So this is saying first order in iodide and first order in thiosulfate. This is the rate law. So when you're writing your conclusion, you would not want to give some kind of generic answer with ABC. You would want to give the specific answer for this experiment. So if this is your rate law, then here's our mechanism. We had the other possible mechanism. This possible mechanism was if we had a rate law that is second order in the iodide. Don't worry about that too. We don't see that often. But if it was second order in iodide, or if it was second order in iodide and first order in thiosulfate. And we should be able to tell this from our data. We should get the same rate law this time that we got with our visual. So the rate law does not change. However, you're going to have to justify it. So we already did the method 1. So that one is done. Okay, so what we're doing this week, oh, sorry, too fast. What we're doing this week is the method 2. So we're using a spectrophotometer, and we do have the spectrophotometers at school, as well as what they showed on your little, on the video. We also have the vernier spectrophotometers. So this is where you start with your procedure. So here's our table of the runs. So the part A is the concentration effect on the reaction rates. And this is your procedure. And we do use cuvettes. And then part B is the temperature effects. So again, we're looking at doing the procedure, doing the reaction at different temperatures. Okay, this is telling us about taking absorption measurements. So in the video that we watched, there was a graph that was made. So we could look at the absorption versus concentration and make a graph. And they gave you the little Beer's law concentration. Oops. Oh, God. The concentration was related. The absorbance equals some extinction coefficient, which I can't type because I don't know how to do the Greek on this. Okay, this is going to run over everything. Let me draw it. Okay, we just want to understand what's happening here. So the video said that the absorbance was equal to some extinction coefficient. Path length was 1 centimeter. Well, this is getting really messy. Times the concentration. You don't need to worry about the 1 centimeter, so we'll just ignore that. So the absorbance is proportional to the concentration. That's what's important to us. There's a direct relationship between the absorbance and the concentration because we could get a constant here and the path length is a constant. So this is what we're going to be able to use. So we're doing different temperatures, we're measuring the absorbance. Okay, so we already did the pre-lab. You do not need to do the pre-lab questions again, you already did them. They're the same ones, they are done. Okay, we did this, you already turned this in, I'm in the process of grading it, taking a while. So we want to look at method 2, because that's going to be our results and discussion for method 2. Oh, here we go. Okay. Oops, oh my goodness, too fast. Okay, so this is going to be where you start for your results and discussion. So you're going to want to fill this chart in, which I believe I gave you the Excel spreadsheet. Oh, look. Calculate the concentrations that were used for each run. We're going to still use the M1V1 equals M2V2. And that's how you're going to get the concentrations for each of the runs for the iodide and the thiosulfate. Okay, so it says plot the A value. That's your absorbance and the time. For each run. So you're going to have a graph that has the A on the vertical. So that means there's your absorbance. And then time on the horizontal. So that's going to be your time. And it's asking you to determine a slope. And notice what it says about the slope. What is that slope? It's the rate. It's the relative rate. So absorbance does not have any units. It'll just be 1/seconds. And you can do this on Excel. So you have to do this for 6. You will have 6 graphs. You can do 6 separate graphs. If you're really good at the colors, you could do maybe 3 graphs on one and 3 graphs on another. That works out well. It gets a little messy when you try to do 6 graphs on one. I mean, you could, but anyway. So you're going to be making all 6 graphs. And then this is asking you to solve some problems here and explain, and then some more answering and more answering questions. And that one you should probably already know. Okay, then this is still part of your results and discussion, but part B. And this one's going to be at different temperatures. There's going to be this, he uses that prime again. So 1 prime, 2 prime, 3 prime, 4 prime at different temperatures. So you're going to have to fill this all out. And it's asking for another graph. So this author, when he's asking for a plot, he asks it that you plot the y versus the x. So this natural log of relative rate is going to be your y, and the 1/over temperature is going to be the x. And more answers. You want to make sure all the answers are in there. Oh, okay. Number 5, just put something. Last semester, everyone put, it would be better if we were face to face. Well, that's an improvement. So, yeah. And then just, yeah, did you learn anything? I think that's it. Okay, so go to our lab archives, our electronic laboratory notebook. And let's find it. Where's my master notebook? Okay, so here's my master notebook. And we're on, here we go. Okay, so we're on the method 2. Let me see. Okay, there we go, method 2. So that's this week, method 2. So again, here's your directions. There's a lot of graphs, which is why this is also 15 points, because the other one was 15 points. But notice this. We don't have to answer the pre-lab questions. Okay, you do have to write a procedure, and you're going to do the results and discussion. And we are still following the general laboratory practices. You might have to go back and review that because there's certain ways that you write. So please fill out the title because it asks you to. Okay, the procedure. The idea of the procedure is if you were in the lab room and you forgot your lab manual, you would still be able to do the procedure. So these are the instructions for the procedure. Some students were very thorough, and some students you would not have been able to follow the procedure. So we want to make sure that everyone gets all the points. It can be bullet points. It doesn't have to be good grammar. This procedure is just what would you have to do. It can be very brief. This many test tubes or this much follow the table, but you would need to be able to follow this. At some schools, when you take organic chemistry, you're not allowed to open up the lab manual. You have to follow your own procedure. We don't need to do the introduction. We already did it. This week, no Beyond Labs. There was nothing that was applicable. So you're going to have that results and discussion. It's pretty long because you have all those graphs to do. Okay, so this was to help you. Some students did not fill this out. I just put this in here so that if you answer all these questions and use your data to support your statement, then this is helping you how to write a conclusion. So yes, you do have to write a conclusion, and please summarize. We want nothing extraneous in the conclusion. We want to get to the point. So you can give some information on the concentration and its rates. You should have some data on that, the catalyst. So you're answering these questions, but please use some data to support your conclusion. And remember, the rate law is specific. It's based on the iodide being first order or second order, the thiosulfate being first order or zero order. So do not give a generic rate law. It's for this specific experiment. Okay, do you have questions about your lab this week?